Good morning, e-learners. We're talking hyperbolas, and by this point, I am hoping that you have seen and taken the notes, because otherwise I'm going to be going through some things that might not make sense to you. I'm not teaching it here. I'm just showing some problems using what we learned in the notes section. So, first off, number 5. Which of the following equations of a hyperbola have a horizontal transverse axis, vertical transverse axis? The transverse axis, for instance, if we have a hyperbola over here, the line that goes through the vertices goes through the foci as well. That's the transverse axis. So I would refer to this as a positive x squared hyperbola, and a positive y squared, of course, is going to open up and down. So here, we have a positive x squared negative y squared. So this is positive x squared. It's opening in the x direction. It has a horizontal transverse axis. B, this is positive y squared, so it would open in a y direction, up and down. It has a vertical. Positive y squared, vertical. Positive x squared, negative y squared, horizontal. So that takes care of about half of, that just based on looking at the equation, I know that this must be opening right and left. I know this must be opening up and down, right and left. It opens in an x direction. This one opens in a y direction, up and down. After that, matching these becomes pretty easy. Most interesting value of x, 0. Most interesting value of y, 0. The center's at 0, 0. And our only choices appear to be here and here. But this opens in an x direction, A. This one opens in a y direction. The center's at 0, 0. Most interesting value of x, most interesting value of y must be D. Here we have a MyVox of 0, a MyVoy negative 3, 0, negative 1. Oh, it looks like we're counting by 2's here. 2, 4, 6, 8, 10. Looks like it might be 0, negative 3, and this one is definitely not 0, negative 3. It opens in an x direction, right and left. Therefore, B, MyVox 2, MyVoy 2, opens in a y direction, 2, 2, C. All right, let's get down to business here. Find the standard form of the equation of the hyperbola with the given characteristics. And I've seen people do these, and I probably would be better to say I've seen people try to do these without diagrams. Occasionally I'll get somebody that's okay without the diagram. Common mistake people make on this, we get so hyperbola minded, we're focusing on the new stuff that we forget the old stuff, and we graph 0 plus or minus 2 as though it was plus or minus 2, 0. X is 0, y is 2, negative 2. So this hyperbola has vertices like this and foci at 4 and negative 4. So this tells me that the center is 0, 0. And then I want to find A, and I want to find B, I want to find direction. I've got direction up and down. I might need to find C as well, or I might be using C. But A is the distance, just like in ellipses, from the center to the vertex, and that is 2. C, just like ellipses, can't spell focus without C. C is the distance from the center to the focus, 4. And just like ellipses, A, B, and C are in a Pythagorean relation. However, with ellipses, A is the biggest. In an ellipse, the biggest distance is from the center to the vertex. Now the biggest distance is C. So we've got 4 squared 16 equals 2 squared 4 plus b squared. B squared is 12, so b is square root of 12, which you could simplify if you like, but we don't need to. So now we're going back to puzzle pieces. This is a positive y squared. Here's the puzzle pieces. We know that we're a positive y squared. We need h, we need k, we need a, we need b, and we've got everything we need. So this is y minus 0, center 0, 0, squared on a squared minus x minus 0 squared on b squared, but b squared is 12, equals 1. Now that process should work for all problems where we're given vertices and foci, and that's a very, very common way to be given information about a hyperbola. So here we go. 2, 0, 6, 0. Let's see, 1, 2, 0, 3, 4, 5, 6, 0. Those are our vertices. Our foci are at 0, 0. So let's find the pieces of the puzzle that we need. The center is halfway between 2, 0 and 6, 0. The center is at 4, 0. We're opening right and left. A is the distance from the center, 4, 0, to the vertices, 2, 0 or 6, 0. A is 2. I've got all of that information. I have everything I need except for B just by being given the vertices. The foci are at 0, 0. So B I don't know yet, but C is the distance from the center to the focus, 4. So C squared 16 equals A squared 4 plus B squared. B squared is 12, and to be perfectly honest, that's what I'm really looking for, what B squared is. And so we've got an x hyperbola, positive x minus 4 squared on A squared minus y minus 0 squared on B squared equals 1. Okay, it'd be a really good time if you're just watching right now. I wasn't certain how to do this. The notes didn't make sense to me. You've now seen 2 problems. It's time for you to put this into use on problem number 15. So pause this video and come back and check. Vertices, right and up, right and way up. So I'm going to do something like this. I'm going to count by 2s here. 2, 4. We're at 4, 0. I'll start with the vertices. 4, 1 and 4, 9. Let's go 2, 4, 6, 8, 9. There's our vertices. So we open up and down. This is positive y squared. Our foci are 4, 0 and 4, 10. So what do we know so far? It's opening up and down. Excuse me. Our center is halfway between 4, 1 and 4, 9. So the average of 1 and 9, 1 plus 9, 10, divided by 2, 5. Our center is at 4, 5, or halfway between 0 and 10. A is the distance from 5 to 9, up 5 to 9, that's 4. I did that again. A equals 4. B I don't have yet. C is the distance from the center, 4, 5, to the foci, 4, 0, they're 5 away. 5 away to 10. So this is 5, so 25, C squared equals 16, A squared plus B squared. B squared is 9, which is really what I want, but I'll go ahead and put B as 3 here. And now, pretty much the only way we can miss this is to order it wrong. But this is positive y squared hyperbola. So it is y, my boy, minus 5 squared on a squared, 16, minus x minus 4 squared on b squared, 9, equals 1. Okay, 17, the dreaded passes through. Let's take a look here. Passes through the point 0.05, which means somewhere down the road I'm probably putting 0 in for x and 5 in for y. Let's see how we can start here. Vertices, very generous when they give us the vertices. Right 2 up 3, right 2 down 3. Let's do this. Right 2, I'll count by 2's here, up 3. So there's 3. There's 2, right 2, down 3. We look like this. What have they given us? They've given us the center. The center must be 2, 0. They've given us A. A is the distance from center to either vertex. So A, I did it one more time. Holy cow. A is 3. B, don't know yet. C, don't know yet. Let's put together what we can. This is a y, positive y squared hyperbola. So that is y minus 0 squared on a squared, 9, minus x minus 2 squared on b squared equals 1. I need an avenue for b, but still giving me the vertices. They've given me quite a bit. They've given me direction, they've given me h, they've given me k, they've given me a. I just don't have b yet. So now I can put 0 in for x, 5 in for y, and I get 5 squared on 9 minus 0 minus 2, negative 2 squared on b squared equals 1, or 25 on 9 minus 4 on b squared equals 1. A mistake I'll see happen is, well, these negatives cancel, but this is really 2 negatives. At this stage, I would multiply every term by my least common denominator, 9b squared. 9's cancel, 25b squared, minus b squareds cancel, 36, equals nothing cancels, 9b squared. So let's see, subtract 9b squared, I get 16b squared equals, add 36, 36, b squared is 36 on 16. Let's reduce by 4, 9 fourths. And b squared is 9 fourths. And to be honest, I don't care that b is 3 halves unless I'm trying to graph this and show where the, or excuse me, that b is 2 1/2, 2 1/4. Holy cow, b is 2 1/4. I really don't care about that. I know I know I just said that wrong. What I care about is b squared. I don't care that b is 3 halves. There we go. Okay, so we end up with y squared on 9 minus x minus 2 squared on b squared. 9 fourths equals 1. Now you may see this, the back of the book might have this, our solution guide might have this as 4 times x minus 2 squared on 9 equals 1. I kind of prefer this. I would accept either, but this really tells more of the story about the hyperbola. So that's it for page 1. If you need anything for page 2, video should be below. Thanks, and let me know if I can help.